To demonstrate writing C#, I'll be using Visual Studio. A good free alternative to this is Visual C# Express, which is one of several light versions of Visual Studio that can be downloaded from Microsoft's webpage. The first thing we'll do here is to launch the project wizard. In the Visual C# section, click the console application. Set the name and location if you want to, and click OK. The wizard will now create a project consisting of a source file called program with a C# file extension. In this file, we've been given some basic code to help us get started. To keep things simple at this stage, I'll go ahead and simplify this, as well as change the class name. The application now consists of a class called MyApp containing an empty main method, both delimited by curly brackets. The main method is the entry point of the program and must have this format. The casing is also important, since C# is case sensitive. Let's begin in the traditional way by creating a program that displays a text string. To find a method that does this, we need to go inside the system namespace and then the console class using the dot operator. In here, we find the writeLine method, which will give a single string parameter delimited by double quotes. We then end the statement with a semicolon. The window shown earlier is called IntelliSense and provides us with invaluable help by showing up whenever there's multiple alternatives to choose from. It can also be brought up manually by pressing Ctrl+space. Variables are used for storing data during program execution. Depending on what data we need to store, there are several different kinds of data types. The simple types in C# consist of 4 signed integer types and 4 unsigned, 3 floating point numbers, as well as char and boolean. To create a variable, we start with the data type we want it to hold, followed by a variable name. The name can be almost anything you want, but it's a good idea to give your variables names that are closely related to the value they will hold. We assign a value to a variable using the equal sign, which is the assignment operator. We can also combine the declaration and assignment into a single statement. If we need multiple variables of the same type, there's a shorthand way to do this using the comma operator. Once we have declared a variable, we can then use it by simply referencing the variable's name. As we saw earlier, there are 4 signed integer types that we can use, depending on how large values we need the variable to hold. The 4 unsigned types can also be used if we only need to store positive values. Integers can also be assigned using the hexadecimal notation, in addition to the standard decimal notation. The floating point types can store floating point numbers with different levels of precision. Notice that the constant floating. In this section, we'll take a look at the operators in C# that are used to operate on numbers. They can be grouped into 5 types: arithmetic, assignment, comparison, logical, and bitwise operators. First, we have the 4 basic arithmetic operations, as well as modulus to get the division remainder. Notice that the division sign gives an incorrect result here. The string data type in C# is used to store string values, which are delimited by double quotes. To concatenate strings, we have the plus sign, or concatenation operator. It also has an accompanying assignment operator, which appends a string to another and creates a new string. Note that although we can break a statement across multiple lines, we can't break a string. Instead, we have to split it using the concatenation operator. If we want to add new lines into the string itself, we use the escape character \n. This backslash notation is used to write special characters, such as the backslash itself or double quote. They also include the Unicode character notation for writing any Unicode character. If we want the escape characters to be ignored, we can add an @ symbol before the string. This can, for example, be used to make file paths more readable. The way to compare 2 strings is simply by using the equal operator. This won't compare the memory addresses, as in some other languages, such as Java or C++. The string class has a lot of useful members for getting and changing the string. For example, methods like replace, insert, and remove. An important thing to note, however, is that these methods return a completely new string. This is because the string class is immutable. Its content cannot be changed unless the whole string is replaced. Because of the performance cost of replacing a string, we should instead use the string builder class whenever we need to modify a string several times. String builder is a mutable string object and has several methods to manipulate the actual content of a string, such as append, remove, and insert. To convert it back into a regular string, we use the toString method. In this section, we'll look at the conditional statements in C#, which are used to execute different code blocks based on different conditions. The if statement will execute only if the expression inside the parenthesis is validated to true. It can include any of the comparison and logical operators. To test for other conditions, we can extend the if statement with any number of else-if clauses. Each additional condition will only be tested if all previous conditions are false. The if statement can also have one else clause at the end, which will execute if all previous conditions are false. As for the curly brackets, they can be left out if we only need to execute a single statement conditionally. Next, we have the switch statement, which checks for equality between either an integer or a string and a series of case labels, and then passes execution to the matching case. It may contain any number of case clauses, and it can end with a default label for handling all other cases. Note that the statement after each case label ends with a break keyword to break out of the switch. Unlike many other languages, the cases in C# must end with a jump statement, such as break. This means that we cannot leave out the break keyword to allow the execution to fall through to the next label. The reason for this is because unintentional fall-throughs is a common programming error. If we actually want to fall through, we have to explicitly show this using the goTo jump statement, followed by a label, which will cause the execution to jump to that label. goTo can also be used outside of the switch, but it's strongly discouraged, since it can quickly become difficult to follow the flow of execution. In addition to the if and switch statements, there's the ternary operator that can replace a single else-if clause when it assigns values to a specific variable. This operator takes three expressions. If the first one is validated to true, the second expression is returned, and if it's false, the third one is returned. In this section, we're going to cover the four looping structures in C#, all of which are used to execute a specific code block several times. The while loop